So this is the second part for which we are going to construct the progression design, our progression design. We are just picking up one part from the template. Of course, it doesn't have to come from the template. You can draw the part yourself. It can be any part for which we want to have the progression, our progression drawn in NAGFORM. So in this particular case, we are going to our templates to the cab screw, and we are going to pick up one typical part. And once we bring it in, then we have a sequence that we want to basically create, and we're going to create all that in our model section only. So I have selected the part from the templates, and now we are going to go through and construct the progression design. Now we're going to work from top to bottom. That means we start from the part, go back one step down. I made a copy of it and I moved it, and now one thing that we have here is that we can actually apply clearance to the whole part. NAGFORM will automatically adjust it. So we are selecting number 6 and applying the clearance. So you have to make sure you put the crosshair on the part on which you want to put the clearance. Now we have removed that primitive. Again, we have to make sure we double click on that particular preform and remove it, and remove the chamfer as well. So now that volume has to be adjusted of the head, because total volume has to stay the same. So now our preform has more volume, and so we can see how much the difference is. It is shown to us on the right hand side. That's the amount by which we have excess volume. So we're going to put that number and subtract it. When we subtract it, it's going to subtract it from primitive number 1, which is the primitive from which we want to subtract. So our volume now is the same. Our union is number 6. We are going to create a copy of it. Again, move that copy, and here now we have to here the operation is to remove the primitive number 4. So I'm going to double click on there. It brings us the dialog box on the right. Remove that. Now once we remove it, we don't have the same volume. So we are applying here the clearance. Whatever amount you want to apply the clearance. This is throughout the part. The part dimensions will automatically be adjusted to include that clearance. And now we're going to make sure that its volume is the same, and we can see the difference between the 6 and 7. That number is given to us on the right hand side. That's the amount, and we are going to put it on number 3, because that's where volume of 3 was used to make that point. So we're going to add that volume to number 3, primitive of 7, and we have now the same volume as the other preforms. So that's our operation second coming from the top. Create the double cone head. So first would be a rod primitive, just the guide portion. Let's say the length is 0.05 and the diameter would be 396, because actually the design involves open extruding as well as making the double cone. So the wire size will be 396. That's what we are going to use. Our design has it. So we made that small guide portion, and now the next thing we are doing is to make a taper. Of course, on the left hand side the diameter would be 0.396, and on the right hand side it's up to us what value we want to keep it. It has to be lower than the diameter of the head. We kept it 0.47, and we select our own angle. So we are creating our own design, just making sure that the volumes are correct and the shape is what we want to get. So this is two primitives that will make the head. Now the third one we are making is the taper on the other side. It's a double cone design. The left diameter is 0.47 and the right diameter is whatever the size of extruded section that we have, which is 346. So now we are creating that taper, and we get to decide whatever angle we want to put. In this case we choose 12 degrees, 12.5 degrees, and say apply. So that's our other side of the double cone design. So on the left hand side, the diameter is the wire from which we are going to open extrude to the diameter on the right, and also head it. So it's an open extrusion plus heading, one operation together. And that head on the left hand side, we're going to replace it with our double cone design. So we are going to first see what is the volume that we have in the head portion, which is in number 1 and number 2 of 7 on our left hand side. And we are looking at what is the volume we have in these three primitives that we have put together. Of course, they have to be less. There is small amount of straight portion in between the two tapers. So we are finding what that volume, what that small portion has, a volume it should have. So basically that's the volume we need for the straight portion. So we're going to construct a straight portion in between the two tapers. We're going to actually specify the volume it should have instead of the length, and that's the ballast volume. We should have it there, and the diameter would be, of course, 0.47, which is the larger diameter. So that's the middle portion between the two cones. So now we're going to click on there, make sure and remove those primitives, and we also have to explode it because it is still a union. So we explode it, and now we're going to create the new union, putting together all the primitives that we have created in the order that we want. It doesn't matter where we draw it. It is going to be joined based on what order we specify here. So the order is 9, 10, 11, 10, and 2. So that's the order. So that's the preform. We can move it around, bring it down here. So that's our preform below. The last one, of course, is very, very easy because that's just going to be a rod. Actually, that rod open extruded and headed into the shape that we have here. So that rod diameter, I believe we wanted to keep it 9.6 or something, and we will see. Yeah, 396, which is on the left hand side. So that volume, and we have to make sure our design is correct. We have to make sure that 396 going to 346, that reduction is less than 30%. All that part of the design we have to ensure in our design that we are obeying the rules. So this is the rod. We are going to move it and that's basically what the sequence is.